All right, we've been put that light on for me for a second. All right, we've been talking about enantiomers, and we know what enantiomers kind of are. They're basically mirror images of each other. You can see that this guy is a mirror image if you look at him. Okay, and we're able to draw those. Now, we're going to have one last confusing thing. Not only do I have to worry about one chiral center, I got to worry about two. I have two chiral centers here. And I've got to worry about how they're arranged around both of them to tell me whether it's an enantiomer or if they're the same, or if it's something called a diastereomer. All right, a disasteromer, exactly. So that's what I'm going to draw today, show you how to draw them, and then I'm going to give you the first worksheet that really you're going to be doing on your own. I'll let you check the answers because, yes, believe it or not, Beaker will do these for you as well. You'll check your answers with Beaker tomorrow, and you'll also be doing a model lab as well. Okay, get that light off for me for a second. So these are called, oh, I didn't open the thing yet. These are called diastereomers, and they're in your notes. There you are. Right. What are diastereomers and how are they drawn? Okay, a diastereomer is, this is a really bad, Emily, you're back over here.
I'm cold. I'm hot.
The diastereomers are, I really hate this definition. It's a really bad definition. Read this definition. Tell me what you don't like about it. What should not be in a definition? Stereoisomers that are not mirror images.
Squamous.
What?
Squamous.
I don't know what that means.
It means
Ask
that you
Mr.
basically.
Gunther. Do you want to know what the definition is?
Yes.
Squamous.
There you go. So, the problem with this definition, I don't know if this is what Mr. Gunther's talking about, is that it has a not in here. You know, like, you can't define something by saying what it's not. Although in this case, you basically are. I will explain what it is as part of the class, obviously, today. I'm going to draw a couple of compounds on here, and we're going to identify them. But then I'm going to show you a couple of tricks, some neat little tricks. I think I'm going to put them on the video, too, because they're tricks that you could use for the rest of the year, well, the rest of this chapter. You're not going to be doing stereoisomers much after this. Let's draw them first. Now, in order to draw this many guys bound around the carbon, around two different chiral carbons, I'm going to use a Fisher projection. Okay, I'm going to use Fisher projection. So underneath here, you want to draw yourself two Fisher projections. Remember what these Fisher projections look like. Okay? Remember what they are. As a matter of fact, on the very back, we're going to do some other stuff on the back today too. But on the back, I want you to, after you copy those two things down, flip it over, the back of the paper, and let me explain what that means. What that is the equivalent to, I'm going to erase this afterward, but look here. What that's the equivalent to is this. Look at here. Looky here. If I look at this guy, the only atoms in the plane of the board are the two carbons, the two chiral carbons, right here. This line right there. These two guys here, they're sticking out at you. And these two guys are going back into the paper. So what really this means is this. And then somewhere on the back, you could put these two things together. This is this. Okay, so write that. That's what that is. Okay? Nobody's actually in the plane of the paper with the exception of the two carbons that are chiral. Everything else is coming out at you or going back into it. And by the way, let's think ahead here for a second. Now that we know a little bit about determining RNS configurations, what would be the best situation for us as far as the lowest, where do we want that lowest priority bond probably to be?
In the back.
Yeah, it'd be nice if that lowest priority bond is back there, either one of these. I'll be able to tell, and you don't have to do this, but I'll be able to tell just by drawing a circle what it is, R or S, whether it's clockwise or counterclockwise. All right, let me erase that guy now and get back to my actual examples. So we're back on the front again. All right? Let me draw these two guys in here and see how, I'll probably do one for you and maybe have you guys do the other one by yourself. All right? F, Cl, CH3, H, I, Br. All right, so there you have it. That's an F. That's an F. Not a very good one, but it is. Okay. Now, can I determine the, well, first of all, what do we have to determine?
Lowest and highest.
Yeah, right. We have to do the priority. So let's do that together. For the top one, you do the bottom one by yourself. All right, let's do the top one first. I'll use brown here. Of the three things, remember, there's a carbon here. There's a carbon there, right? That's not just a cross. Who's the heaviest thing bound around him? What atom do you think? Cl? Everybody agree it's Cl? So he's number 1. Who's number 2?
Fluorine.
Fluorine is number 2. Now, we have a tie at number 3. I've got a C up here. I've also got a C down there. Who wins?
The C with the Br.
Yeah, the C down here is bound also to a Br and iodine. So this whole thing is number 3, and that guy is number 4. Now, I used brown to do that one. You do the priorities for these guys, because they're different. You know, you have to use looking at this carbon, and that guy up the top will be a different priority. So see if you can assign those for me, and then I'll do them for you. Make sure you get them right. Okay, I'll use red for those. I'm sure you got 1 and 2 for iodine and bromine, right?
Mm-hmm.
Who's 3?
The carbon.
And a whole big guy up here is 3.
Hydrogen's 4.
Hydrogen's 4. Okay. Yes. Now, those priorities don't change for over here. They're the same, okay? But to keep my paper a little cleaner, I'm not going to do them right now. I'll do them in a little bit. Let's just do RRS for each of these. Why is the top one easy to do the RS for? Take a look at it. Where's my lowest priority bond at the top one?
And back.
Lowest priority bond is already going in the back, right? So all I got to do is connect the dots.
So fast.
1, 2, 3, and it's going this way. Which is that the way? What's that? Clockwise or counterclockwise? Counterclockwise. So that makes him S. Absolutely. You see why? Now I'm going to give you a little hint here. There's a lot of other neat little hints I'm going to give you in a little bit. Watch this one. When I go to do the red one at the bottom, I don't have my lowest priority bond going back into the paper. I have it coming out right at me, don't I? Before. See it here? Hydrogen's coming out at you. So whatever I draw for this guy, 1, 2, 3, what do I know it's going to be? The opposite, because here's what it really means when you have that situation. What it means is your compound looks like this. Oh, here, let's use hydrogen where he's sticking out. Well, I want him to be on the other side, like he is over there. So let me just move some guys around here. You're used to seeing the yellow as hydrogen. So let's pretend that that's the hydrogen I'm trying to do right now. Okay, right, sticking out at you. I actually, in order to look down that bond, I got to look from behind the board this way, don't I? So whatever I'm drawing this way is going to be the opposite if I'm looking at it from the other direction. This guy looks like 1, 2, 3. Looks like he's R, but in reality he's really what? S. And so if a guy is on one of the ones coming out at you, whatever you draw as your circle is actually going to be the exact opposite for clockwise and counterclockwise.
And can it be opposites, but then what would that whole thing be?
What do you mean?
Like, you know how, like, what if one was S and one was...
Well, that's what we're going to talk about right now. We're going to get there. All right. Right now, I don't have a name to this. It just is what it is. The question is, how is he related to him? Well, we got to do the R and S configurations for that guy too. What will happen? Let me just think ahead for a second. What would happen if I find these two guys? Y'all watching now? Let's use several possibilities. Let's say these two guys come out to be S and S. That guy's S and that guy's S. What do I know these two guys are? They're the same, right? He's the same as him. Agreed? Same compound. What if I get R and R? What are they now? They're both mirror images. The whole thing's a mirror image. Therefore, it's a... Which one? Which particular? Enantiomer. Right. Enantiomer. So what's the other possibility I could have here? Yeah, I can have one guy is R, but the other guy is S. Now, you notice how it doesn't fit my classic definition of an enantiomer because it's not a complete mirror image. It also is not identical. I don't have both of them being S's. So this is the weird thing that's a diastereomer. When you have one guy who is a mirror image, but the other one who is not, I call that a diastereomer. Okay? So let's see which one this, by the way, comes out to be. I'll erase this. Let's see. Applying my priorities again. Number 1, 2, 3, 4. All right. What did I tell you about this now? Let's think about this. Where's my lowest priority bond? He is a wedge coming out at you. He's coming out this way. So whatever I draw here, 1, 2, 3, it looks like I'm drawing what? What does that look like I'm drawing? When it goes this way, 1, 2, 3, what is that? Is that counterclockwise or clockwise? Counterclockwise, but in reality, because the guy's coming out, he is clockwise, he is R. Okay? Can you see why I don't need to do this one again? Can anybody see it? This is going to be another hint I'm going to give you in a second. No, not based on that. H-I-V-R. It's exactly the same thing I have written over there. So, what do I know this guy has to be? An S. So now, it's exactly what we said we were worried about happening. We have a guy who is an enantiomer, or not an enantiomer, a mirror image, there a guy who is not. That makes him, they're actually identical, that makes him a diastereomer. And that's what this guy is, a diastereomer. That's why he's underneath there. Okay? These two guys are diastereomers of each other. Yeah.
I still don't understand how you know it's going clockwise.
Well, clockwise or counterclockwise is very easy. I connect the dots, connect the bonds from highest to lowest priority. He's number 1, 2, 3. All right, that is, how does the clock go? Clock goes that way. Look, clock goes that way. This guy's going the opposite of the clock, right?
What's in the bottom one? Like 1's over here and 2's down here.
Well, let's take a look at the bottom one. All right, let's look at the bottom one. Once you put your priorities, you simply connect the dots. Here's 1, here's 2, here's 3. I'm drawing clockwise, right? But since this guy's coming out at you, I have to reverse that because I'm actually looking at it backwards. I'm behind the board looking out this way. That's why, like I said, if you have to have a guy coming out at you, whatever you draw, it's going to be the opposite.
That's why.
Well, and there's really 4 possibilities. I think we saw this yesterday, not just with these guys, but with this guy. Let me show you these. All right, there's 4 possibilities. All right? If I've got my lowest priority bond right there, he's number 4, all I've got to do is draw the circle, one way or the other, right? Whatever he is, however they connect, that's what the answer is. What if my lowest priority bond were here? Whatever circle I would draw now, if it were 1, 2, 3, went around like that, it's the exact opposite, because he's coming out at you, isn't he? You see?
So if it's on the side, then you don't.
Well, not just the side. You can't use the word side. The dotted line going in, you're gold. Everything's good. Just connect the dots. The wedge coming out, exact opposite. These other guys, well, it kind of depends, but pretty much we talked about this yesterday. Let's take a look. Okay? If I've got a compound where my lowest priority bond is drawn straight up, let's draw one like that. Okay? So here's my H. He's my lowest priority bond. He's my 4. And let's just say he's 1, and he's 2, and he's 3. Okay? What can I do there? Well, here, I got to get underneath him, and I got to look straight up. If 1 is out here, 2 is out here, and 3 is over there, what am I drawing? Okay? 1's right in front of me, 2 is out here, 3. 1, 2, 3. What am I drawing? What is that? That's an S. All right? But when I connect these dots, what does that look like? R. So basically, if you have the guy at the top or coming out at you, whatever you draw, I mean, this is a bad way to teach it to you because I don't want you to just memorize. Okay, if it's here or here, I got this. If it's here or there, I got that. I want you to understand and be able to manipulate it in your head. That's why, guess what we're doing tomorrow? we're bringing the models out. We're going to make all of these guys. And you're going to get to see them and manipulate them in your head so you can see them in 3D. Okay? I'd rather that than having you memorize. However, knowing that you want to memorize, and knowing that sometimes some people actually need these tricks, let me show you another neat little trick. Watch this. Say I've got guys like this. I'm just going to use letters. Don't write these down. And these, I think, when I'm done, I may have you put them on the back. But I want to just try it first. Neat little thing about these. I can actually get the answer of whether they're enantiomers, diastereomers, or identical very easily. Let me show you. I know what that guy is right off the bat. I know if he's an enantiomer, diastereomer, or identical. You say, how could you possibly know? They're just letters. They're not priorities. I don't have any atomic masses. All right, number one. And number two, how do you do it so fast? Let me show you. You can actually tell if two guys, because you have a common frame of reference in both of these cases, the bottom one is always sticking down. You can actually tell if these guys are identical or not. Watch. Just choose any element. I'll choose B. And then draw a circle in one direction. Doesn't matter, clockwise or counterclockwise, but the same direction. B, C, A. Start at B here. Draw the same direction. B, C, A. Did I run into the same things in the same order? Yes. The top is equal. Let's try it down here. Doesn't matter which one I chose. I chose that guy up here. I'll choose this guy here. D, E, F. D, F, E. Is the bottom identical?
No.
No. I know it's a diastereomer. How about that? I know that's a diastereomer. I can figure that out in a matter of 30 seconds without doing whether this is R or S or R or S. I can just figure it out by that little trick. The little trick. See that? All right, let's try it again. Only to show you some stuff on the back here. Watch this. Choices. Let's say I find the top half is equal and the bottom half is equal. What do I call that? Write this on the back. Top half is equal, bottom half are identical. What do we call those guys?
Enantiomers.
Nope. They're not enantiomers. What are they? Top is the same, bottom the same. They're the same. They're not isomers at all. They're the same guy. If I find that this guy is an R, and this guy is also an R, this guy is an S, and this guy is also an S, guess what I've got? The same thing. I'm always amazed when I get to this point. I have to do this. And that's why I'm doing it now. You kind of forget the easy stuff when you get to the harder ones. What if I get this? Not equal, not equal. Both of them are unequal. If neither one of them, they're both mirror images, right? This is a mirror image. When I say unequal, what I mean is mirror image. Okay, when I go to do it. Right? Well, they're both mirror images. What do we call that guy? Enantiomers. And now the new one we just learned, unequal, equal. What do I have there?
Disaster.
Disaster. Diastereomers. Okay? And the possibilities of this aren't endless, but they're many. For example, does it have to be R, R, S, S in order for it to be equal? No. It could be R, 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 R. S, 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 S. S, S, R, R. It could be any one of them, right? Same thing's true for here. The top half is unequal. That could mean that this guy's R and that guy's S. Bottom half is unequal. That could be R, that could be S. It could also be SR, SR. Or, vice versa. It could be R on the top, S on the bottom. Okay? So there's multiple possibilities for all of these. But those are your three possibilities, really, in reality. Those are your three possibilities. And you do remember my little trick now, right? How do I tell them apart? Very quickly. By the way, this trick's going to come in handy in the first worksheet I'm going to give you in a second. It doesn't matter if it's a chlorine, a bromine, or a CH3. It doesn't matter if it's an A or a B or a C. All that matters, and you can put this one on the back for you to try it on your own right now. Okay? You tell me, what is this guy? All right? Try that. Tell me what he is. Without doing R and S. You obviously can't do R and S for A, B, and C. But you can tell me what they are. Enantiomers, diastereomers, or identical. And you do it by comparing the top half first, seeing if that's the same. Comparing the bottom half, seeing if that's the same. And it should only take you about 30 seconds to do it. Doesn't matter which guy I choose, but let's choose one. Cl, Br, CH3. Cl, CH3, Br. Are they the same? No. They're mirror images. By the way, you might be wondering, well, don't we run into this guy? No, that's my frame of reference. Remember, what you're doing is you're using this guy, this bottom bond as your frame of reference. So all you're looking at is these three. 1, 2, 3, 1, 2, 3, whichever way you're going to hit it. Same thing down here. Doesn't matter who I start with. A, B, C. A, C, B. I do a circle in the same direction, starting with the same guy. Do I run into the same stuff? No. So he is not the same. They are mirror images. If they're both mirror images, what do I call these two compounds? Enantiomers. How about that? All right. I'm going to give you that worksheet.